Hello students, we'll start with next part of unit 2, that is 2D transformations. So now we know that a graphic system must allow the user to change the way object appears. In real world we frequently rearrange objects, right, or look at them from different angles. The computer should do the same with images on the screen. So we can change the size of an object, its position on the screen, or its orientation. Now it must, we can say, be more sensible to implement such a change. Like we can say that we can change the object's originals or basic descriptions. So all this comes under transformation. So basically we can say transformation means making a change or allowing modification to the pictures. So main part in this comes is matrices. Now computer graphic images are generated from series of line segments which are represented by coordinates of their endpoints. So certain changes in an image can be easily made by performing mathematical operations on this coordinate system. So before we go in detail of various transformation, let us see one or two, we can say, mathematical tool which are used here, that is matrix multiplication. You all know what is matrix multiplication, I guess. We have already solved the problems also. Like see, for matrix multiplication, here in 2D transformation all calculations are done using matrices, that is matrix multiplication, matrix addition, but the main basic method used is matrix multiplication which is required. Now we'll see basic transformations on 2D images. So first is translation. Now moving the whole image is called translation. We can say we can easily shift the image by adding some value to all the points of the image by which we want to shift the image. So if we want to shift the image down by 5 units, then we have to add -5 to all the y values of that image. Similarly, if we want to shift the image by 5 units, then all you is to add 5 to all the values of image. Same thing for x values also will go. These are the translation matrices, and tx and tr are the translation factors. So suppose this is the image, we are moving it above, so the whole image gets shifted above. Now what is rotation? Rotation, as the name suggests, it rotates the object from one place to another in a particular, we can say, angle theta, So if we have derived rotation matrices with respect to origin, but we can say that that in the case we have to follow the point of rotation is other than the origin, then we follow a series of transformations. So these transformations are called as composite transformation. Like rotation, here any two-dimensional object which we are rotating from one place to another with any angle theta is called as rotation, change the place of an object. But if now all these things we have seen are in case of with considering the origin as a point, but if the rotation is about an arbitrary point, then we cannot directly use the matrices for rotation. For this we need composite transformations. So what are composite transformation? We have to follow some steps, that is translation, rotation and retranslation. Now what is translation? By translation you will move that object to origin, then after that you will perform rotation, and after that you will again retranslate the object to its original position. All this is done if the rotation is about any arbitrary point and not about the origin. Did you get it? Now what is next is scaling. What is scaling? See, translation is shifting the object, the whole object, from one place to another. Translation, rotation is rotating an object about any angle theta. And what is scaling? Scaling is basically changing the size of an object or image. So suppose we are having point P1 whose coordinates are x1, y1. Then we can represent this point P1 in a matrix form, right? The dimensions of that matrices will be obviously 1 by 2, that is one row and two column. Now suppose if we want to multiply this point matrix by some another matrix, say matrix T of dimension 2 into 2, then we get resultant point P2 with dimension as 1 into 2. So to get it, P1 into T, the matrices will be P2. Now P1 is 1 by 2 matrices and T is 2 by 2 matrices, so the result will be 1 by 2 matrices. Here Sx and Xy are the scaling factors. See, scaling actually changes the shape from A to B, from this to this. All the calculations are done in homogeneous coordinates. Like for translation, the translation matrices is given. For rotation matrice, and for scaling is the scaling matrice using its factors. So we'll repeat with the three basic transformation. That is, first is for translation, tx ty as the translation factors, and this is the basic homogeneous condition or the matrices for translation. Then this is the matrices for rotation. We have to use this matrices directly, so you must know its contents. Then homogeneous coordinates for scaling. What is composite transformation? As we already see, when we concatenate many matrices together or different transformations together, it is called as composite transformation. Now we have seen this mainly in case of rotation. Rotation about any arbitrary point cannot be done directly. For this we need some composite steps. First is to translate, then rotate and retranslate. This is an example. Which was solved in class. Suppose a square with vertices this is scaled 2 units in x as well as y direction about this fixed point which is center of square this. Find coordinate of vertices of new square. Now the square is scaled, so scaling is to be done. The scaling factors are Sx is 2 and Sy will also be 2 as 2 units in x and y both direction. It is not around origin, it is a fixed point is given, so arbitrary point 1 1 is given. So here we cannot do directly scaling, we have to do composite transformation, that we have to club different transformations together. So translate, bring into origin, then do scaling and again retranslate, let it go at its original place. So translate with translation factor tx ty, that is 1 1, then perform scaling with scaling factors 2 2, and then retranslate with retranslation factors, as it will be here 1 1, so it will be minus 1 minus 1. So do matrix multiplication and you will get the result. After you get the transformation matrices, multiply this transformation matrices with the original vertices of the square and you will get the transformed new vertices. We'll also go in, we'll see other transformations available. Other transformations are reflection and shearing. Now what is reflection? Reflection takes place like a rotation is done about an angle theta. Similarly, reflection takes place from one plane to another, we can see, and about an axis. So reflection about y-axis, reflection about x-axis, all the reflections are different and gives different result. So the matrices are different for all, like reflection about x-axis, reflection about y-axis, and reflection about origin. So these are the transformation matrices for reflection about y-axis. Like see the reflection, this is original image, it is reflected for y, then it comes on this side of y-axis. For x-axis it is here, and if it is reflected it will go downside, that is about x-axis. And these are the reflection matrices. Next is shearing. Shearing transformation means we can say that changing or slating the image. The shear transformation is basically of two types, that is Y shear and X shear. Y shear, in Y shear we are keeping X coordinate value as it is and shifting the Y coordinate values only, which results in tilting of the horizontal lines. While in case of X shear actually preserves the Y coordinate values and shifts the X coordinate values, causing vertical lines to tilt. So this is shearing. Like if this is the image, after X shear it will look like this. It is changing, these 2 points are changed from one place to another. This is for Y shear. If this is the original image, after Y shear that is changing, this points for Y axis will get the resultant image. So these are basic 2D transformations. Let us revise once again all transformation. First is translation. Now what is translation? Translation is changing the place of an object or shifting the object from one place to another. Translation factors are tx and ty. Now next is we can say rotation. Now rotation is rotating an object about an angle theta. So if the rotation is about, we can say if it's about origin, we can directly use the rotation matrices. But if the rotation is about any arbitrary point, then we'll do composite transformation, that is translation, rotation and retranslation. Now next is scaling. Scaling is change in shape of an object. Here also scaling matrices is used and the scaling factors are xx and sy. Same here, composite transformation takes place if scaling is to be done about an arbitrary point. In that case, first we'll translate, then scale and retranslate. Did you get this sequence? Why we translate first? Because we'll shift that object to the origin, then perform scaling and again retranslate or reshift the object to its original place. For this purpose we need to perform these steps, that is translation, then we perform the basic transformation which is required and again retranslate. So this is translation, rotation, scaling. Now I'll say what is reflection. Reflection is reflecting an object from one plane to another or about a particular axis. So reflection about x-axis and y-axis gives out different matrices which are to be used accordingly. And last one is shearing. Shearing is done about y shear or x shear. It is basically, you can say, slanting the image. Whenever we need to slant the image, for that shearing is used. Shearing matrices for y axis and x axis are different. So there are basically two methods, that is y shear and x shear. So this is 2D transformation. Problems on 2D transformations are very easy. Directly matrix multiplication is performed. If you don't know a proper or you are not good at matrix multiplication, do practice it, or else the calculators which we use, the engineering calculators, they directly do matrix multiplication. So use that device and directly put the values and get the answers. But don't do mistakes, silly mistakes in this, as these are guaranteed marks. Only just remember the matrices and the steps to follow. So don't skip marks or don't do silly mistakes and give away the marks because of matrix multiplications. Okay, thank you.